So today we're going to be talking about significant figures, and significant figures are a way of looking at numbers that have been written down and determining which values are well known and which values are estimated and which values have no significance and should not be counted. There's three categories. There are numbers that are not zero, and if they've been written down, then they are automatically considered significant. So say someone's written down the number 5.23 milliliters. Then all three of these values are considered significant. The first two values, the 5 and the 2, are well known, and the third value is the estimate. But we could say we have three significant figures in this number. When we talk about zeros, zeros fall into three different types of categories. And those categories can be leading, as in to the left of a number, trapped between numbers, and trailing, as in to the right of a number. Like this is to the right of the three. The leading zeros are never counted because if we cover up the number and we just show the zero, nothing has been measured yet. Nothing's been measured here. It's not until we get to that 2 that we begin our first measurement. And also, we could rewrite the number in scientific notation, and we don't even need these numbers to the left because they're really just placeholders. So the 2 and the 1 are the first well-known values, and the 3 is the estimate. Trap zeros are always counted, because without those trap zeros, the number doesn't make any sense. It's not even the same number. Let's say we cover up this 0. That's a drastically different number without those zeros in between. We're most likely going to see trap zeros in this class when we have a measurement on like an electronic balance. Say something is 40.05 grams of calcium. Well, we know the scale is well-known values are 4, 0, and this 0, and the 5 is the estimate. So there we have four significant figures. Trailing zeros are the hardest of the zeros, and they're only counted if there's a decimal point. Here we have two different examples. With this one, none of these zeros are considered significant because there's no decimal. So the whole thing is just a giant estimate. Something weighs 3,000 pounds. Well, the very first value is an estimate. But if someone wrote down 3,000 with a decimal, they're trying to convey that the 3, the 0, and this 0 are all very well known, and the estimate is the last 0. Where are we most likely going to see this? Again, maybe on an electronic balance. You put something on the scale and it reads 12.40 grams. Well, the scale is telling you the 1, the 2, and the 4 are well known, and it's estimating the last value as a 0. The third area we're going to see numbers in has infinite significant figures, and that's for definitions, constants, and counted objects. For definitions, these are exact things. 1 meter is 100 centimeters. 1 foot is 12 inches. Things like that. They never vary. They're always the same relationship. For constants, things like pi keep going and going and going. They don't have an ending. So those are also considered to have infinite sig figs. And then counted objects. You know, there's 8 slices of pizza. You would look down and you'd actually see 8 slices of pizza. There'd be no doubt about it. I want you to pause the movie and try to evaluate how many significant figures are in the 4 numbers on the page in front of you. Okay, hopefully you've taken time to share with people around you and you've evaluated these 4 numbers. The first one has leading zeros, which are not counted, followed by 4 values. So those are 4 significant figures because the leading ones don't count. This number here, 30 without a decimal, well, that's only going to have one significant figure. There's no decimal, so only the 3 is counted as being significant. And even that's a guess, because there's only one value. For this one, we have 4,000 with a decimal. That decimal is telling us that all of these zeros are considered significant. So here we have 4 significant figures. And for the last one, well, this one really depends. Did you count 26 students, or did you estimate it was 26 students? I was thinking, in this case, that someone went around and counted the students. And if you counted the students, then it would be an infinite number of sig figs. You might also write 26.00000 and just let it keep going. Um, but anytime you have a counted value, it's an exact value. Therefore, it's an infinite number of sig figs. Now, if you just looked in a room and said, that's about 26 students, that would only be 2. But I was thinking this was a counted value. The next part in the notes references rounding. Rounding is the same in chemistry as it is anywhere else. You look at the value you want to round, and if it's 5 or higher, you round up. And if it's less than 5, you drop it off. So say we wanted to take this, and we only wanted to show 3 values. We only want to show 3 significant figures. Well, we look at the fourth value, which is a 2, and since that's less than 5, we're going to drop it off, and we record 34.5. With this one, we'd have 27,993. Well, the fourth value is a 9, so we'd have to round it up, which would make this 28,000. It does create a little bit of a problem, so we're going to have to put it in scientific notation, so we only show 3 significant figures. I want you to take a moment and round these values here that are at the bottom of the page, and then these values here, which are on the next page, to the appropriate number of significant figures. These two you're rounding to 2 sig figs, and these two you're rounding to 4 sig figs. Let's go ahead and pause the movie and take about a minute to round these. Well, okay. So this one, the first two are the 5 and the 2, because these leading zeros are not significant, and after the 2 comes a 0. So when we round that, we'd finish off the number like this. And then here, the first 2 is a 3 and a 0. So we're going to drop the remainder, the 0 and the 5, but we do need that decimal, because without the decimal, the 0 is not considered significant. And then on the next page at the top, we have 40.002. Well, the 2 is the 5th value, so that's the value that's going to be dropped off, so just be 40.00. And then lastly, for this one, I was thinking a teacher has an average of 28 students per class, meaning she's measured several different classes, and now she's calculating that her average is 28 students. So you're no longer counting students, it's a mathematical operation. So if we wanted to round this to 4 sig figs, we would write 28.00. Now we're going to move on to some of those mathematical operations in the next video.